This is a sprite sheet. It contains 1, 2, 3, 9 different graphics. And right now we are just using the entire texture and just paste that right on the screen. And we want to change and only use some of the texture, because then we can, for example, like in this one, first use this one and then this one and then this one consecutively, and then we have an animation. Or we can have a huge spreadsheet that contains all of our graphics, so that we can just load one texture and per level, and we're happy with that. For example, we can have all the tiles in a single texture for drawing the background, and then we just exchange that single texture when we load a new level, and the level will get an entirely new look. So we're going to make a method which will calculate based on an index. We'll pass in an index. This is 1, 2, 3, and so on. We're going to use as an example passing in the number 5. So we're going to try to get this middle square. But before we do that, we're going to need a few things before we start with the actual method. We're going to define a new field. Right now we have the texture that we can use at the entire width of the texture when we do calculations. So we're going to need a new field that is just the size of the actual image that we are using, not the texture. So let me minimize that, and then we go over to the image, and we go to fields, and we add another field here. Private vector. That sounds good. We can call it size. Can collapse that, and then we go over to initialize, because we're gonna have to set this one as well. This object has a size which we want to put a new vector in, and right now we're just using the entire texture, right? I think it was 128 we used before. We'll do that for now, and then we see if we crash anything. So right now we're using the entire texture, but that's just because the box is the entire texture and the cursor is the entire texture. We'll change this later on. Okay, let's do that new method as well. This region is for the main methods, and this is going to be a new method. So I'm going to make a new region, and in this one I will collect all the methods that belong to initialize. So we're just going to have a CalculateSource method in this one for now. I can close the region up too. Okay. Let's let's make it private for now. We can change it later on if we need to access it from somewhere else. It's going to return a rectangle, and the name was CalculateSource, and we need to pass in that index I was talking about to define which image to use. As you can see, the method is going to need two things to be able to calculate. It's going to need the index and the size. But I define the size as a field because that one is going to be the same all the time, but the index is going to change depending on which frame that we're going to use. Put a curly bracket in there also. and then we move on. We're gonna need to know what happens when people pass in different kinds of numbers for the index, right? So we're gonna have an if statement. Let's have some error checking in this as well. I'll bring back that image and I'll show you. If somebody wants this one, they pass in 1. We're gonna pretend to pass in 5 in the example. But what happens if somebody passes in 0 or even less than 0 or 15? We're gonna have to have some error checking as well. So let's start with that. Let's say that if they pass in 0 or less, then we'll use the entire texture. So if index is less than or equal to 0, then we will use the entire texture. So we'll just return a new rectangle, and it wants 4 coordinates, right? We'll use 0 for the upper corner, and we'll use this object has a size which has an x, and this object has a y coordinate too. Now remember that a rectangle wants integers, and this size is not an integer, this is a float. So we're gonna have to convert it to an integer. Could be done implicitly, but let's do it explicitly so we practice this new concept. And that's about it. We're happy with that. But if index is not 0 or less, then we're gonna have to do a lot more. Let me close this up right away so we don't forget to do that. Okay, I'll try to make this as clear as possible. So I'm gonna define some variables so we can use the labels of those instead. I'll explain this. I'll just type it in first. Frame column equals 1. We're gonna define two variables. We're gonna define 4 more, but let's start with these 2. I am setting the frame row to be the same as index. This number is too high. Let's use that example of number 5 here that we want to get to this one. But I put frame, which row is this square in? I'll start with a number that is too high. It's row number 5 down here. If you imagine that we have 2 more rows down here. And then the frame column, which column is the frame in? It's actually number 2, but we'll start with number 1. And then later on in the code, I'll increase this number and I'll decrease this number until we get to the right spot. But before that, let's define frame width, and this one is just the size of the x that we defined up in the initialize method, or initialize there. And then we do frame height. If I can spell. And we do just the y for that one. Maybe it's more logical to have the column above the row. Doesn't much matter. And then let's also define the total amount of columns, total columns that we have. So how do we do this? Well, It's not that hard. Let's say that this is 300 and this is 100. Sorry. Then we just divide 300 by 100, and that should be fine. So we have the texture. Sorry, this texture. This object's texture contains a width that we can just divide by frame width. And then, oh, sorry, and then we do the same thing for total rows. This object has a texture with a height that we can divide by frame height. Let's say we passed in 5. Then we start down here, and for the frame row, it's going to be same as index, and frame column is going to be 1. So what we're going to do is we're going to increase this by 1, and then we're going to subtract as many as there were in that column that we got rid of. So we're going to have 5 minus 3, and we're going to have 1 plus 1. We're going to increase frame column, and the frame row is going to be decreased by total rows. By doing this, we go from 5 up to 3, and we go from 1 to 2, so then we end up in the right spot. However, what if we would have wanted this one instead? We passed in 9, then we would have been down here, and we would have gone up to 6, right? When this one increased to 1. So we would have to do all of that one more time. Increase this one more time to 3, and then decrease this one by 3 to get to the right spot, right? We're gonna have to surround this with something. I'll click W, and then we'll pick a while statement. While frame row is too much, then we're still out of bounds. While it is still more than the total rows, then we need to execute these two statements over and over again until we find the right place to be. Okay. Let's finish up with a little bit of error checking. So we'll check if somebody passed in a too high number. If index is more than the total rows times total columns, then something is wrong. If that's the case, we need to set frame, I'll move it up a bit so you can see. Then we need to set frame column to not be more than total columns, right? And we need to do the same thing for frame row. It can't be more than the total amount of rows that we have. Okay, that looks pretty good. Now all we need to do is return all of this. So we'll return a new rectangle. And I'll hit enter because we're going to do some typing. I'll type it first and then I'll explain it. Frame row times, frame column times frame width. The first value, we wanted it to be, if let's say we wanted to do 5. Frame column is 2, right? And frame width is, let's say that this is 300 and this is 100. Then frame width is 100, right? That means that we're going to get the value 200. So we're going to end up over here, which is wrong. So in order to fix that, I'll subtract 1 like that. And then we do the same thing for frame row. We'll subtract 1 from that one as well. And then we have frame height instead. Okay, and the width and height, they are much easier. We'll just do the width and height because we've got them. And I'll finish up like that. That should be pretty good. Now that we have this nice little method, we can go up to initialize in the main methods and we can use it. Remember that the CalculateSource uses the size. So we have to initialize source after we initialize size. So here we're going to pass in, we're going to pass the ball to CalculateSource, and since this one is for the entire texture, then let's use the entire texture. So I'll just pass in 0 for now. Now we can change that later on. A few more things. Origin uses source, so that one needs to be initialized after source. But there's one more thing that at least temporarily we will have to do a little bit of an ugly hack. The CalculateSource is using the texture, right? Well, we can't for sure know that XNA will call load graphics and fix the texture before it calls initialize. In fact, most of the time initialize is called before, which means that when initialize runs down to CalculateSource, CalculateSource is going to try to use a texture that hasn't been created yet because load graphics content has not been called yet. We can add that ugly hack for now, and then whenever we have a entire class to load resources, when we change levels and stuff, then we can fix this. But for now, let's just call load graphics content in the initialize method. We want to load all the content, so we'll pass in true. Okay. I think that's about it. I'm gonna start debugging and see if it crashes or not. No, it looks pretty good to me. It looks the same as before. So, but that's okay. Let's talk a little bit about generics and type parameters, and then we can actually use this new thing to make an animation.